Morning, everyone. I'm Julius, Director of Product Management at Juniper Networks. I'm really excited to be part of this kickoff of Openstack event here in Istanbul. We are going through this transformation of the cloud technology is impacting every aspect of technologies. How we develop software, from how we deploy software, from how we enable these workloads and how we connect them and move them and store them. So at Juniper Networks, we see these transformation as an opportunity to shorten the path to revenue for many of our customers. And today's session, I'm going to talk about how this transformation also impacting the service provider side, the concept of telco clouds, how that virtualization is becoming ubiquitous, and the local domain controls of software-driven virtualization with the centralized orchestration, with the right level of abstraction, with the enough right infrastructural intelligence, is enabling the network to become not only a programmable platform, but also a revenue-generating platform. So in today's session, I will be talking about how do we operationalize this? What are the imperatives to operationalize this so-called enabling the network as a revenue-generating platform? And I also would talk about some of the enabling capabilities of the Openstack to make that possible. So before I go into that, let's peek into the market, how the drivers are enabling and moving on that front. So the cloud we talk about, it's a means to an end. Why people are adopting this cloud is to get certain drivers behind it. Many of them want to use network services on demand when they want it and what they want it. Not only the operator enabling on demand, even an ability for end customer to go and demand certain services through a self-service capable portal and get deployed immediately. And also another cloud capability is about elastic resources. Traditionally, operators build their network capabilities for peak demand, and things are underutilized. So what cloud is providing is the ability to elastically move these resources to be consumed. And the next one is pay as you go. You want to pay for what you're using. And the fourth one I could see is the fast fail model that over-the-top providers have mastered. You wanted to have an ability to introduce a new service and test out the adoption. And if it's failed, how do we move into the next one? This is the key part of moving into these service innovation and service agility. And finally is about automation. The cloud is more of a software-driven automation at every level, from underlay, overlay, to the control points, to the orchestration point at the business logic level. And with that, you could see how the IT and networking are coming together. Some of the stats, like this is a 2014 stat, it talks about how by end of this year, 70% of the enterprises would have adopted a hybrid cloud, either private or public. And in another 2 years, the market of spend on these cloud-enabling technologies is whopping $400 billion. It is a real market, real opportunity. And what is driving that is by end of last year, 91% of the softwares are built for cloud delivery. What does that mean, cloud delivery? These softwares are built with microservices that could be scaled proportionally on demand, on responding adaptively to the market demand. That is a new way of developing software, and that is what's happening. And this all happening, look at the growth from private infrastructure as all aspects of the cloud is growing at mid to high end of 20%. So this is a real market, real opportunity, and they are solving real problems. And why these operators are moving and adopting this cloud? They have real pain points. They are declining revenue. They cannot adapt their network to the demands of the customers. So the revenue is declining. Why? The CapEx, the assets they deploy is inflexible. So they buy these fixed function solutions that are purpose-built for certain use cases which get outdated, and they cannot adapt to the change. And all these things are traditionally been managed with a lot of complexity, a lot of manual configuration, a lot of touch points. So maybe we talked about cloud as a computer. In here, people are programming in assembly language, right, the network. So what are the use cases? This software-driven virtualization is these SD and NFV technologies coming together and enabling. I think Jennifer has pointed out that business virtual CPE, where the enterprises are connected with this simple, traditionally, the high-function hardware as a CPE device in every customer premises. And now, in order to manage that, you have a lot of truck rolls. In order to manage that, you have these high CapEx costs. The cloud technology is enabling, the adoption is big, is you provide a simple layer 2 CPE device and customer premise and suck all these high functions into the cloud. You have an economy of scale. You have these CapEx savings, you have operational savings, new revenue opportunity where enterprise can, on demand, through self-service portal, can ask for new services and get it delivered. The service chaining, which is the important part of mashing up these services. These NFVs, they could mash up together, and enable new innovative services. That's happening in the mobile cloud, that's happening in the virtual CPK, in the data centers. It's also happening on the edge. So on and so forth. These are real use cases. These are real cloud is getting in transforming how the telco cloud is getting built. So next, I want to talk about some of the the imperatives for operationalizing this network as a revenue generating platform. These are real things happening in many of the early adopters in the telco cloud. So centralized versus distribution. So centralizing a lot of functions for economy of scale versus distributing some certain functions to the edge for enabling better user experience. It is not either or. It is all about the hybrid nature of flexibility of enabling these virtual functions wherever they want, whenever they want model. It's a hybrid model that's here to stay. So that ubiquitous virtualization either in the data center, centralized data center, all the way to the edge. With the local domain control, where software-driven control at the domain level, and the centralized orchestration, which taking a more of a network service level view, controlling and rolling out services is a key in enabling this network as a revenue generating platform. So in the centralized case, we touched upon how the virtual CPE can go and get the services from a centralized data centers, but there's also an effect of universal CPE where some of these functions can be easily placed on a compute-enabled edge. So it's not only in the wireline, it's also in the mobile side. What's happening is there are a lot of, the RAN is getting virtualized. So in the cloud RAN model, there are the baseband controllers are getting split, and some of the layer-to-layer function is virtualized, and the central offices and POPs are cloudified. What that gives them the capability of putting some network function layer of caching, the network functions of security, with the capability of understanding your spectrum usage in the mobile So this would enable these innovative services that give you better user experience. And also, these are foundational elements that are put in place for future IoT use cases. So these are the platform. This network is becoming a programmable platform where these cards compute are enabling future use cases you haven't even thought about. Next imperative, I want to talk about the service mashup. It is a key enablement of service innovation, how you chain these services. And also, how you chain the services doesn't have to be pre-planned and built for years. It's more of a dynamic. You understand the market group, understand the demands and interests of the customers, and they should be able to create these service chains. They should be able to work in more abstract level with the business. So you have to enable solutions where it's not the technology specialist who understand the protocols who design this. You have to be able to abstract it out so that the business people can be able to enable these service mashups with the right level of infrastructure intelligence. So in this type of mashups, you can imagine how this type of abstraction has happened in the computer industry, right? So in the early days, these computers have been programmed with assembly language, more binary code. But as time progressed, in order to increase accessibility, these structured programming has happened. And over time now, it's all about frameworks. So it gives you the accessibility and the flexibility to innovate on software. Similar thing, as a network, as a computer, now the network has to evolve and provide the right level of abstraction at every level to enable this type of service innovation. Next is, it has to be evolutionary. We are all looking for revolutionary results, but it have to be, the solutions and architectures need to be evolved. That is critical piece for adoption. The reason is there are a lot of technologies and infrastructure have been deployed. And also the emerging technologies have some challenges in enabling all the use cases. So, and also the organizations are also transforming. The ITs have been looking only at the compute level, and the networking has been looking at the network level. Now they are converging to become DevOps model. All these challenges are in place to quickly transform into the world of virtualized world. So it's important as we roll out solutions, these have to be evolutionary. The evolutionary means some of these network services that span across multiple domains have been able to stitch the physical functions to virtual functions. And some of these domains are controlled by already cloudified to take an Openstack. But some of these domains are other, like VMware, or some are more custom built. How do we build together and enable these evolutionary solutions? It's key in bringing this telco cloud in a more evolutionary model. And then the other imperative is the automation. Automation is key. If you look at the Etsy model, there's a manual layer. That's where the Openstack sits. That's where the NFV orchestration sits. And this is the key in bringing the software-driven automation. But not only that layer, you also need to bring automation at the physical functions layer, the virtual functions layer, and also the SDN control all the way to the business logic. So in order for you to bring these remote devices that we are talking about that are getting compute enabled, you need to be able to bring them on board through zero-touch provisioning. You would be able to enable these virtual functions wherever the flexibility you want to enable at. You want to manage these as a life cycle event from end to end. So the automation at every part, every layer is key in order to react and respond to the on-demand services. And this is the foundational element for making the network as a platform to deliver services. Finally, the tunnel to isolate. So you have this underlay complexity, the spine switches to top of the rack switches, and the servers who can have multiple VMs and containers, all these complexities there. But what the virtualization gives you is the way to tunnel and build these overlay networks. So Jennifer has talked about how Contrail, through network and neutron plugins of the Openstack, can build these tunnels. This is where you provide that clean abstraction of isolating these tenants. This is where you isolate even the complexity of the underlay. So this type of abstraction and overlay networks are enabling not only virtualization at the compute level, also at the networking level. So these are the key imperatives. This is not a comprehensive list, but it's happening, and these are the ones that are enabling this transformation. Next, I want to capture some of the OpenStack capabilities. They underpin and become the force behind enabling these imperatives. Before I look into that, you can look at how, this is a recent report from Infinetics, a couple of months old, where they did a survey saying which is a preferred platform for the VIM, Virtual Infrastructure Management Layer, which OpenStack. OpenStack becoming the leader. Even though VMware is deployed in more enterprises, the OpenStack is becoming more and more adopted into the service provider world. And I want to also mention here that Juniper's IT is powered by OpenStack. So it is a really, as Juniper, we are committed, even we are running OpenStack and powering our IT with OpenStack here. So we talked about this abstraction. We talked about how where you can now build these service mashups with the right level of infrastructure level intelligence. How do you go and make it realized? So that's where the heat comes in. So when at the network function orchestration level, if you go and build these network services, you provide these descriptors and you chain them together in a way that you think that you could make revenue. Essentially, these need to be transformed into more of an infrastructure level instructions. And heat is one of the infrastructure, it's a more of a YAML based model. So we call it HOT, the heat templates. It's a human readable template. But how that works is OpenStack sees the underlay and the overlay as resources. Server is a resource, network interface is a resource, even IP address is a resource. So when you have this abstraction, when they go through transformation engine and produced into heat instructions, where you create parameters, you define these resources, you provide resource relationships, and even resource dependencies, and the output you are interested in. These are all specified, and this is programmatically pushed into heat into the OpenStack. And OpenStack now, the heat engine knows how to orchestrate at the infrastructure level these instructions. How do I bring up a particular resource? Which resource I need to bring up before the other next resource? This all the workflow is automated. So heat plays a key role in bringing this top-down declarative model of making the realization of the highly abstracted network service. Next, placing this VM. So if there is a network function as DPI, these are compute heavy. How do we know where to place that VM? There would be caching, which is storage heavy. How do I place this VM? So in the OpenStack, that's a construct of region. So we talked about multiple domain, a central office, POP, data center. These are called regions. That's where the whole full stack of OpenStack is deployed. But the keystone, the security part, and the horizon could be shared. But within that region, now you have this VM placement problem. How do we place the affinity rules? How do you place the anti-affinity rules so that you place certain function to the appropriate cluster of compute? So what that concept is called aggregate host. So OpenStack have an aggregate host where you define this metadata. Within the metadata, you optimize it for energy usage, you optimize for compute, you optimize for storage. And this aggregate host is published as availability zones. So at the abstraction level, you place certain functions of your chain and associate them to availability zones. And these zones are later on produced into heat. And part of heat engine, it knows when I instantiate this VM, which cluster that I need to bring this cluster on. The next service in the chain has to go in a different cluster. And then they all need to be service chain, the tunnel concept I talked about. So it is playing a key role in bringing and enabling this type of intelligence into the abstraction. Next capability I want to talk about is the autoscaling. So OpenStack has this capability to define these autoscaling rules because you want to dynamically respond and adapt to the end user demand. You could specify these scaling groups, scaling policies, and you would be able to now respond and trigger based on accelerometer. It monitors, for example, a key performance indicator, for example, the CPU. That would trigger, and it would trigger a new instance to autoscale. So these are important aspects of the OpenStack. These are not a comprehensive list, but these are the enabling aspects to make this network as a revenue generating platform. We talked about virtual CPE, how as a use case where now through a self-service portal with a simple connectivity into the cloud, enterprise can go and go through this NFV orchestration where the abstraction level network service and realized as a VNF that is either universal threat management to a simple firewall. These flavors are described, these flavors are activated, they're getting realized underneath. With this, I just captured the essence of how these telco clouds are transforming, the imperatives and the capabilities of OpenStack. But they are all for a reason. Because the challenges we talk about, revenue, OpEx, and CapEx challenges, these are getting addressed through service mashups. So in the fast fail model, you would be able to accelerate your revenue. And through capital optimization about cards compute is moving to every part of the domain, you're bringing economy of scale. And finally, the operational efficiency through automation. These are key drivers, the key enablers who address the pain points of telcos that are happening. Finally, at Juniper, we want to drive these solutions in a turnkey, integrating best of solutions components from Juniper and the best of breed ecosystem partners. We also understand its evolutionary part, as I mentioned, about fusing the performance with the flexibility. And finally, enabling built on open. Our contract platform is open source. We are building a lot of solutions with open standard protocols. They are hardened protocols, and also enabling REST APIs at every level so that we can seamlessly integrate it in a multi-vendor solution. So essentially, our goal with the turnkey evolutionary and open is to how do we make these shorten the path to revenue and increase agility. With that, thank you very much.